Okay. Welcome to Knowledge Search channel. In this video, we will be discussing about a power electronic equipment or device, that is current source inverter. As you all know, current source inverter, there are two types of, basically we just classify broadly into voltage source inverter and current source inverter. Okay. So already we have posted some videos on voltage source inverter, okay, 3-phase voltage source inverter and other things. And if you are really very interested in it, you can just go back and you can see in the playlist voltage source inverters. Okay. So in many of the industries, most of the voltage source inverters have been replaced with current source inverter because of its better functionality and better risk free. Okay, because normally in case of voltage source inverter, there are many chances of getting the devices to be short circuited. So suppose if we are using the same device in the higher rating, for example in megawatts range, what is going to happen if there is a short circuit? It will create a big damage, or it may even big fire will be there. So most of the industries which go with inverter with high ratings, in case of for example in megawatts range, they use this current source inverter. Okay. So again current source inverter are used in very high rating rated industries, okay, for controlling the output current, controlling the output power in case of high power. Okay. So that's what I just want to convey over here. So before going into the, I just want to give you some small difference between a voltage source inverter and a current source inverter. See, for example, if you take a voltage source inverter, what is going to happen actually? See, the output voltage is constant. So in case of voltage source inverter, the output voltage is constant and it is load independent. What do you mean by load independent? That is, even if the load changes, the voltage is not going to change. Is it right? So that is what we observe in our normal household. Is it right? So in our houses we use that is the output voltage is always constant irrespective of change in load. There is not much major change. Is it right? So that's why that source is called as a voltage source. So here, whereas the output current is going to change with respect to load in case of the voltage source inverters. So in this voltage source inverters, they will be using a large capacitor at the input DC side. Okay, it will be used in parallel. Okay, the large capacitor will be used in parallel at the input DC side. So as I've said, there are some drawbacks when we use the voltage source inverter in a high power ranges. So in order to overcome that, they found out the inverter called as current source inverter. So here what happens is the current remains constant, the output current remains constant irrespective of changes in load. Okay, the load, whatever there may be a change, the output current will always remain constant, whereas the output voltage will be changing with respect to load. So this is the main difference between current source inverter and voltage source inverter. So in case of current source inverter, the short circuit problem is completely eliminated because the output current is always constant and it is load independent. That is, the magnitude of the current will never change when there is a change in load. Okay, only the output voltage will be changing according to the changes of load magnitude. Is it right? So ultimately the power is going to change. Power is nothing but the voltage and current. Either the load voltage has to change in order to deliver power, or you have to change the load current. So in case of voltage source inverter, the output current will be changing with respect to load, whereas in case of current source inverter, the output voltage will be changing with respect to load in order to deliver the required power to the load. So how you design this current source inverter is, you will be having a large inductance in series with a DC input. For example, if you are having a DC input voltage and if you connect a large inductance, then it will behave as a current source. This is what has been already discussed, and it is the thing that is available at present. Okay, so how to convert a voltage source into current sources, you have to connect a high inductance in series with the voltage source. And you know that when we connect a large inductance in series with the DC input, the change in current will be taken by the inductance, and because of which it will behave as a current source. Okay. So what are the applications of the current source inverter? So as I've already told, it is used in AC motor speed control for in range of megawatts. So in range of megawatts, if you want to control the motor speed, then current source inverter is the best choice. And for induction heating, for example, if you want to do heating of chemicals or heating of so to some in many process industries we use heating. So in that case, CSI is a very best option when compared to the VSI. So VSI is nothing but voltage source inverter, CSI is nothing but current source inverter. So induction, in case of heating in terms of megawatts range, okay, you have to go with CSI, okay, which is really a very economical solution when compared to the VSI. Also, it is highly protected when compared to VSI. Okay, and also it is used in lagging war compensators. What is it, lagging war compensator? So, for example, in case of transmission lines, okay, I have to supply some current in order to match the reactive power. I have to supply the current because the load is changing with respect to time, and because of which I want to supply the VAR, that is the voltage reactive power, in order to, you have to inject, okay, in the transmission line. So those transmission line will be of high power rating, and in that case we have to go with the current source inverter. And similarly, in some of the cases, in order to start a high megawatt synchronous motor, again the CSI, that is current source inverter, is used. Okay, so basically if you go with the types, you can see that it is broadly classified into two types. One is the transistor based, the other one is the thyristor based. As you all know that transistor is used for low power rating, whereas thyristor will be used for very high power rating. Okay. So similarly, transistor based we will be discussing. So anyway, this for the scope of this particular video, I cannot extend all the explanation of all the circuits in one video. So I am just going to give you some small introduction of all the things, and I will be showing some circuits and some waveforms, and what are the applications, and where we go in for different which type will be used for which particular case, and all those things we will be discussing here. Okay. So transistor based, there is no type, okay, in case of transistor, whereas in case of thyristor based there are two types. One is the CCCSI. What is the CCCSI? That is capacitor commutator current source inverter. The next one is ASCII. In short, it is called as auto sequential current source inverter. So it is in short it is called as ASCII. Okay, ASCII. This is CCCSI. So this is called as capacitor commutator current source inverter. So thyristor based inverter are classified into two types. There is no classification in case of transistor based. So transistor based are used for low power application, whereas thyristor based are used for high power application. ASCII is used for very high power application because it is very costly, as well as it is highly safety and highly protected. Okay. So for medium ranges we can go for okay, this is how it goes on, right? And okay, so this is how it looks like. So this is the transistor based inverter. Okay, this is the transistor based inverter, that is current source inverter, transistor based current source inverter, and adjacent to it I have given the waveforms also. Okay, so you can see that that is from the circuit, you can see that there are 4 transistors and 4 diodes are used. Is it right? You can see that 4 transistors and 4 diodes are used. And what is the use of these diodes? The diodes are used to plot the reverse voltages which will be appearing across the transistors. See, for example, if I don't connect this diode, then there will be a heavy reverse voltage which will be appearing across this transistor, and because of this the transistor may get damaged, and you want to replace this transistor quite often. So because of that, in order to avoid that, we are using this diodes in series, whereas in case of VSI we will be using in parallel, whereas here I am using it in series. Okay, so you just understand. And similarly, you can see that the input current will always remain constant, okay, because it is a current source inverter. So here you can see that a heavy inductance is connected. Okay, voltage source is there, a heavy inductance is connected, and a combination of voltage source in series with a high inductance, that is called as a current source inverter. Okay. So this is the circuit diagram, okay, and how it works. Okay, so how it works. So see here you can see that initially, for example, I am just dividing, okay, the intervals, 0 to T1, 0 to T1 to T2, T2 to T3, T3 to T4. Okay, so if you first I will explain for 0 to T1 how it operates, then I will go for T1 to T2, then I will go for T2 to T3, then I will go for T3 to T4. This is how I will just go on. Okay, so you can see that the drive for T1, this is drive for T2, and this is drive for T3, and this is drive for T4. So you can see that this is how the switching sequence for T1, T2, T3 and T4. So diagonally opposite, the switching sequence is very, very important. This is T1 and this is T2, this is T3 and this is T4. Okay. So you can see that there is a small delay between each and every sequence, and you will be getting the output current something like this. So here, in order to control the load, we are going to control the for example, the output current, okay, because the input current is always constant, so I have to control the output current, and what voltage magnitude can be changed according to the load requirements. Okay, so here you can see that from T1 to T2, you can see that T1 and T2 will be in conduction. Okay, so for example, from T1 to initially we want to discuss about 0 to T1. So you can see that T1 and T4 are in conduction. Okay, so here you can see that T1 is in conduction, and similarly T4 is also in conduction. T1 and T4 are in conduction. Okay, and you can see that no current will be flowing. Why no current will be flowing? Because already short circuited. The supply is short circuited, but whether the current will rise? No, because it is a current source inverter. So the load current will always be 0. Okay, the supply current is passed by T1 and T4, and it will not create any short circuit because the input current will always remain constant, right? Because it is nothing but a current source inverter. So next is from T1 to T2. Okay, that is from T1 to T2. You can see from T1 to T2, you can see that what happens. So T2 and T3 are in conduction. Okay, so the supply current will be flowing from T3, D3, T2, D2. Okay, the supply current will be flowing from. So you can see that from T1 to T2, that is T1 and T2 conducts. Okay, so T1 and T2 conducts. Okay, so T1 and T2 conducts. So you can see that the supply current will be flowing through like this. Okay, so it will be flowing through like this. Okay, so there will be some small output waveform will be there between the interval T1 and T2, because the current will be flowing through the load. Is it right? So similarly, you can see that the load current will be in alternating nature. So for example, then again I have got the positive cycle. Next I have to go for the negative cycle. So from T3 to T4, what I am going to do? You can see that from T3 to T4. So T3 to T4, you can see that T2 is again switched off. Okay, and you can see that T4 comes in again. So in this particular time, T3 and T4 are in conduction. So T3 and T4 are in conduction. Okay. And similarly here between T2 and T3, you can see that T2 and so here like this. Okay, so similarly you can observe. So here the current will be 0. So whenever the transistors of the same leg conducts, the output current will be 0. Whenever the transistors of the opposite leg conducts, they will be getting a positive current or negative current. For example, if I am triggering T1 and T2, you will be getting a positive current. If I am triggering T3 and T4, you will be getting a negative current. So like that, so by adjusting the pulse width, you can adjust the magnitude of the output voltage as well as the frequency can be adjusted. So this is how this particular transistor based CSI can be only used for R load. Okay, that is what I just want to convey. So if you want to go for high power rating and for RL load, it is advisable to go with capacitor compensated current source inverter, and even very high rating ASCII is best, that is auto shrink compensated current source inverter, the best one. Okay, so like this you can see that the supply current keeps on flowing continuously, whereas the current is kept constant by connecting a large inductance in series with DC supply. So the output voltage is adjusted to keep the current constant. Okay, so now we will move on with the next thing, that is this is the circuit of the capacitor compensated current source inverter. Okay, so here you can see that it is a bridge type. Okay, it is a bridge type, and you are using a R load. So and capacitor will be connected in parallel with the. So you can see that the capacitor is connected in parallel. Okay, so what is the use of this capacitor? So the capacitor is used to store the charge in order to force commutate this SCR. So if the capacitor is not there, then this thyristors cannot be switched on. Thyristor cannot be switched off. So in order to commutate this T1 and T2, I am using this capacitor, and similarly in order to commutate the T3 and T4, I am using this capacitor. So that's all for this capacitor commutated current source inverter, and you can just understand that when I switch on T1 and T2, I will be getting the positive current, whereas when I switch on T3 and T4, I will be getting the negative current. So I am getting an alternated output current, that is positive current as well as negative current, because of which the output current is AC, and so similarly the output voltage also should be AC. So like this it goes on. Okay, so this is how it works. Okay, and so beyond this you can and similarly vice versa. Okay, so T1 T2 positive, T3 and T4 negative, like that it goes on. Okay, so now we'll, so as I've said, it is used for medium power rating, and okay, and it is used to for R load. Okay, so next if we go for RL load, the capacitor compensated current source inverter will fail. Okay, there are some problems with that if you use the same capacitor compensated current source inverter for the RL load. So in order to achieve it, we are going in for the ASCII. So this is nothing but your ASCII, that is auto sequentially commutated current source inverter. So this is circuit diagram of your ASCII. Okay. So here what happens is you are having two different capacitors, okay, so which is used to store the energy for commutation. Again, the capacitor used only to store the energy to commutate the SCRs, okay. So again, you have seen that four diodes are used. So this what is the use of this diodes? Okay, what is the use of this diode? So additionally, you have this four diodes. The thing is that the difference between the previous circuit and this circuit is there is a capacitor, instead of connecting in parallel, you have divided into two. Okay, two capacitors are there. Similarly, four diodes are there. That is the difference. Okay. So what is the use of this diode? So this diode, what it is going to do is it is going to prevent the capacitors from discharge during the commutation period. So if you don't use this diode, then what is going to happen is the capacitor will discharge during the commutation period. The capacitor will discharge, and there will not be enough voltage to commutate the SCR. So in order to avoid that, we are using this actually. So similarly here also, when I trigger T1 and T2, I will be getting the positive output current, and when I trigger T3 and T4, I will be getting the negative. So T1 and T2, I will be getting the positive output current. T3 and T4, I will be getting the negative output current. So you can see that because I am getting both positive and negative currents, the output current is AC, okay, and so this is actually main working of actually this current source inverter of high rating, that is auto sequentially commutated current source inverter, ASCII. In short, it is called as ASCII. And so just a basic difference, voltage source inverter and current source inverter. Voltage source inverter, the input voltage is maintained constant. Current source inverter, the input current is maintained constant and is adjustable. In voltage source inverter, the output voltage does not depend on load. In current source inverter, the output current does not depend on load. The magnitude of the output current and its waveform depends upon the nature of the load impedance. Is it right? So load impedance, based on the load impedance, the output current will be changed. Whereas in this case, based on the load impedance, the output voltage will change. And in case of VSI, there is no need for any feedback diodes, whereas in case of current source inverter, does not require any feedback diode, but some diodes in series is needed. And similarly, the commutation circuit is quite complex in case of the voltage source inverter, whereas in case of current source inverter, the commutation circuit is very simple and it contains only the capacitor. So that's all about the current source inverter, and really thank you for your being with me. And if you really like this video, please give a thumbs up. As well, if you have any doubts, you can just comment. I don't have much time to see the comments. I hope if I see, I will just reply back. And if you really feel that this particular video will be useful to someone, please share it. And as well, if you really like the videos which I post in this knowledge share channel, please subscribe to my channel, and which will give some motivation to put more videos. So thank you.